Christine Fitzgerald from Perfect Squares Tutoring. Today's question asks us to find the angle to the nearest degree between the line 2x plus 3y equals 12 and the positive direction of the x-axis. Okay, whenever you are finding the angle between a line and the positive direction of the x-axis, there's a formula you need to use, m equals tan theta, where theta is the angle you're trying to find. So it's related to the gradient, and it's because gradient is rise over run, tan is opposite over adjacent, and they're effectively the same thing. So what's our gradient first of all? Well, we can't easily see it yet, so let's find that first. 2x plus 3y equals 12. In order to find the gradient of this, I need to get the y on its own. So 3y is 12 take 2x, and therefore y is 4 take 2x over 3. And so the gradient is negative 2/3. I need to now put that gradient into this rule. So m is equal to tan theta, therefore tan theta is negative 2/3. Put that into your calculator and you will press theta is the inverse tan of negative 2/3, and you'll find that you get an answer of negative 34 degrees. Now negative 34 degrees doesn't sound that helpful. And if we have a look at what the line looks like, it was 4, so y-intercept of 4, take 2x over 3, so a negative gradient. Okay, now the wording of the question said, find the angle between the line and the positive direction of the x-axis. Positive direction of the x-axis is going there, so there, and the line, and it's always the angle above the x-axis. So that's it, and it definitely makes no sense to say that that's a negative angle. What it is an obtuse angle. It's bigger than 90 degrees. And a very quick way, without explaining the theory, to convert your negative angle into the correct obtuse angle is to add 180. So if I add 180, and you can do that on your calculator, whatever, you're going to get 146 degrees. And that's the required answer. If you just want to remember that, like if it comes out positive, if you've got a positive gradient, you'll get a positive angle, no dramas, and it'll be acute. But if you've got a negative gradient, your calculator will give you a negative angle, and you can always add 180 to get the correct obtuse angle that's required. But for those of you who would like more explanation and understanding, let's draw a unit circle. So I've got 0, 90, 180, 270, 360. The calculator quite correctly said it's negative something, negative 34 degrees. So it's there. But where else is tan negative? A, S, T, C. Tan will be negative. Positive there, negative here. So it could be there. Positive there, negative there. And that's what the calculator came up with. We want this one. We want a bit bigger than 90, but less than 180. We want that. So that's why we have to add 180 degrees on, because instead of being in the fourth quadrant, we want our angle to end up in the second quadrant. Well, I hope that makes sense, and I hope that is of some use to you. Thanks for watching.